That's okay. Okay. So we've just finished trying the one first free response. It's a block on a ramp with a pulley and another block. We tried for 15 minutes just to see if it was a complete disaster and to see what it felt like to try those problems in 15 minutes. And actually, probably that's so. If you're changing your mind a lot or you're trying different things, that feels a little fast. But actually, that's not too fast, is it? Like there was really, you probably exhausted your knowledge, right, in 15 minutes on all those things, right? If you couldn't finish, it's because you had to guess, right, and you didn't know what to do, you didn't remember. We'll fix that, okay? So, oh yeah, for people in class and online, what I want for tomorrow, or coming up soon for online people, I want you to take, because now you have the answer key to those 15 multiple choices. I want you to take your 15 multiple choice. Do not erase any of your work. So there should be an initial attempt in pencil or whatever pen you used, and then do corrections using some other writing utensil, some different color, pencil versus pen, whatever, some way I can tell the difference. Okay, and for people in person, we'll hand those in at the start of class tomorrow. That's your first homework. And then we'll actually be using the book. You have the book. Did anyone look at Canvas over the weekend? That's fine if you didn't. I don't. But there is a PDF now of the book. Did you try to get the textbook PDF? Okay. Did it work? Some people said it worked. Let me know if it doesn't work right away because so the issue is, and I should be able to fix the rest of them today. If I have to host that file in Google Drive because Canvas doesn't have enough storage space. So, but if I first put it in a Drive file and that whole file isn't shared with the whole corporation, all students and teachers, then it sometimes gives you an error when you try to get in. It says access denied because I at first denied people access. Rats. Well, I think after today I can fix those permissions. Okay, for today, you might want to leave the book here. We're going to use the book a lot in class, but you're allowed to bring your personal technology and have a PDF of the textbook. You should probably, before you make the decision, you should probably look at the PDF, see if it's acceptable. And there's no book homework for tonight. Okay, take the multiple choice you already did, take the answer key, check them, and maybe we should have some time today to ask questions. Okay, so today and tomorrow, we're going to learn how to answer these. Did it occur to you to show your work and show your steps? Ooh, this is free response. So some person, a physics teacher like me, sometimes a calc teacher who wants extra money for grading physics problems, has to look at this and read it. That's why this one's not being scored officially, it'll just be completion. But when you really do this, someone has to read it and judge your work. And they're going really fast. So if they can't read it because you write like wavy chicken scratch, or if you write super tiny, actually they have good glasses. They probably can read neat but very small writing. So I wouldn't. I see some glances going around. Right, some of you now it's coming back to me from last year. Some people can write so small that that might be an issue, but I'll tell you that it is. But if you're one of those people who likes things super tiny, try to go a little bit bigger, or at least make sure it's obvious for an old person like me, right? Like, yeah, because a physics or calc teacher who's grading this, I'm turning 40 this year. It's going to be someone probably aged 40 to 60. I've never gone and done it myself for the extra cash. It's usually not close by. Everyone gathers in one city. Okay, students set up 2 blocks. Fantastic. In initial setup, calculate the value that would allow it to remain in equilibrium. Oh, perfect. And one mass is 3 times the other. Okay, all that matters is do we have friction? The friction for this part 1 is negligible. I think there is still time to change your classes because after this problem, I think you're going to really hate College Board. I choose this first one on purpose. Okay, so there's no friction. So you've got m1, I'm going to write cursive, m1g sine theta, and on the other one you got m2g, and for equilibrium, oh, they better be equal. Yeah, that's right, they better. Okay, so m1 was really 3 big m's. That's why I don't want to do the big M's if I can't mistake it, because you got to substitute and not forget your 3. 3 big M's times g sine theta. So, and really, if I really wanted to get full credit, I would write not only those two things equal, but right by this word equilibrium, I would write the sum of my forces is equal to 0. And there's lots of math symbols for therefore, but I like a double arrow. Therefore, m1 g sine theta equals m2 g. Okay, 3 mg sine theta equals just big mg. Okay, so that means sine of theta, the g's will cancel, the m's will cancel, sine of theta is 1/3. Oh dear. And they said calculate. Okay, there's a bunch of buzzwords. Actually, they're supposed to be helpful hints, but when College Board says calculate, they do want the numerical answer, but they want 3 steps. So we'll start to learn their code. If they said, so they definitely want a numerical answer, and they want 3 sig figs. So I'm wrong to leave it inverse sine of 1/3. Okay, both degrees or radians would be right. So look, I'm reaching for my calculator the first time on the free response. Multiple choice, I wouldn't even touch it. Inverse sine of 1/3. Okay. Double checking that it is in degrees. So I would say 19.5 degrees. It might take a while, don't worry. That's why I wait 5 or 6 weeks for the first test. So there, I need to show 3 steps. Hey, this is a step. The sum of the forces is 0. That's 1 step. That's 2 steps. Okay, the forces that add up to 0 are actually these 2, and I don't need to write, like this is advanced physics. Calculus physics teachers grade these. You don't have to write this minus that equals 0 because I wrote this. No. Okay, the sum of the forces is 0. Here's an equation that comes from that, that's forces. Okay, and then the third step is, actually, oh yeah, the third step is substituting these. This is my 3, because here I used M1 and M2. And if I'm in a super hurry and I just write this, that's probably okay. Because we can really, like, you can really jump steps. You can go really fast. Yes, sir. Ooh. The question was asked, does diagramming, I assume free body diagramming, count as a step? If it's me grading it, I would absolutely count it. That replaces your forces adding up to 0 step. You need one equation. Okay, I would not accept, I would not give 3 out of 3 points or whatever this is without showing an equation where you have sine of theta in it and some values substituted. Okay, so before I was hassling you about in honors physics about showing work and showing steps. Maybe you didn't need to. Okay, but now we're up against these problems. I deliberately had a couple of tests that were free response tests. Okay, momentum, and also this one. You had to show your work. So every time they say calculate, try to get 3 steps on there. Just 1 step, but not all, can be replaced with a diagram, I bet. Sometimes it will ask for the diagram. And then I must have the numerical answer with degrees, or you could put radians and radians, they have to accept it. Any questions? Maybe thumbs up quietly if you've got that. Oh, only a few. Okay, that's okay. We're going to start over with like equations of motion, Lord of the Rings test. Easy stuff to begin with. But we'll quickly be back at block on a ramp. mg sine theta better come right out. Okay, so my video isn't super long. Okay, now we have a rough surface with coefficients. Oh! You ready to stab College Board? How often do you think they change the problem like this? So we had a part A, we did some steps, we got an answer, and then they changed the problem. And you look a couple more steps, and they change the problem. Practically every step they're going to change the problem. That was just a starting point. This really is 5 little problems that you have to solve. And if you're not experienced, they're not little either. Okay. Now there's coefficients of friction. Block 1 is again chosen for big M. Okay. Derive an expression for the maximum value that will allow the system to remain in equilibrium. Okay. It doesn't even say that the ramp's the same angle. So if I need that number, I'm going to use my same number. And they won't count off for this, even if it was wrong. Okay? I need that number from part A to do part B, probably. But it doesn't even say that it's one with the same angle. It just says it's replaced with a rough surface. Ugh, with some coefficients. Okay. Glance back at my mark before I'm really humiliating myself. Okay, 3M. Oh no. There's my unknown G sine, we'll call it theta 1, equals, uh-oh. We're going to have to replace this. So in equilibrium, again, we'll have our sum of forces equals 0, equals big mg. The maximum value of m2. Wait a minute. Oh! College Board will tell you they don't make any mistakes. Even though they just said block 1 is again chosen, it wasn't 3M before. And now they want the maximum of block 2, where it will still hang on the ramp. That actually helps us out a lot. Because if we were changing the sliding block, like there's an equilibrium where the masses are perfectly balanced and friction's not needed. There's an equilibrium where M2 is trying to drag the block up, but friction just saves it. And there's an equilibrium where M1 is trying to drag the block 2 down, and friction just saves it. Whew. But now we know. Okay, this is getting pulled up. What does friction do? I've had AP students all summer, because they had extended time and technical difficulties and whatever, emailing me about the AP test. And usually it's about friction. Do you remember from honors? Maybe for a bonus point. What does friction always do, Aiden? Of what? Not quite. That's good enough for half. Let me write it down. Oh no, I'm going to lose my leash. Okay, I saw Ben next, I think.
It's always a subtractive force, so it can't do any work on its own.
Okay.
It can only do negative force.
Ooh, okay. It can't do positive work. Friction's so negative. Right, so I asked what does friction do, and I got it opposes other forces. It opposes things, so I'll give you half for that, not necessarily forces. Friction can't do positive work because it's always taking mechanical energy out of the system and generating heat instead. That's true. That's not quite what I was looking for, though. How do I know whether friction goes up the ramp or down the ramp? Is it the same direction as mg sine theta, or is it the opposite? And I drew that arrow backwards because I'm bad at stuff. The mg sine theta component is going to point down the ramp. Does friction point up or down? We did so many of those problems. And now you have to automatically know, because we have 15 minutes to solve this problem. I'm going to talk the whole time about it, sorry. Okay. Do that in red. What I have to remind the AP students, even the summer they take the AP test, is friction opposes motion. That's what it is. Friction is just microscopically those rough surfaces of the thing. The atoms are like getting in each other's way. They're like scraping, scratching across each other. Okay. What's really fun is like metal atoms can do that. They just shift around on the surface. They don't even come apart. You're not like scratching anything off, but you're forcing that surface to deform. Stay with me, Jeffrey. We need a break, huh? Friction opposes motion, or if it's stopping motion from happening, like rolling without slipping, it's opposing the motion that would happen if there were no friction. So really, it's got to have some in-depth thought there. So we need to replace that, just mg sine theta. If it's going to be if we're not for friction, we want the maximum value of m2. So the friction in this case will also be down the ramp. So we can do big mg sine theta plus big mg times that mu, my terms are out of order, cosine theta equals xg. The system remains in equilibrium. Do I need mu s or mu k? They give them both. Sure.
It's got to be UK, right, for this one, because it's going in the same direction as.
The direction, we already decided the direction. M2 is trying to drag M1 up the incline. We should be writing some notes about this. Friction opposes the motion of being dragging up. Okay, because that's how our equilibrium would fail. Okay, so mg sine theta always points down. That's my positive direction. And so in this case, mg cosine theta with friction will also point down. Yes, sir. Yes. Okay. Why did they even give the kinetic friction? It should be static because they're jerks. They want to count that step wrong because you put the wrong one. And if you just left it mu, or if they only said mu s, it would be too easy. Oh, they want you to remember my video with the little ticking talk and this reciting the numbers and the guys didn't know the earth goes around the sun and stuff. It's pretty funny. They think like so to answer this at speed, you have to have memorized mg sine theta, mg friction times cosine theta. Okay, that's to come right out. They're hoping you're not going to stop and think because you're under such time pressure. You're not going to check. You have to have already thought about it by the time the test really comes. So that's and they're taking advantage of that fact. Okay. Well, look, we lose our g's. Now we better know that it's 19.5 degrees. Hey, that's not so bad. And you can just solve for x with the calculator. Express your answer in terms of big M. Okay, so I don't. And physical constants. Rats. Well, hey, the sine was 1/3. Ooh, if the sine is 1/3, what's the cosine? We have any master mathematicians? Big M times 1/3 plus mu s. Is it 2/3? Square root of 2. I can't think about that. I'll admit it. It's inverse sine of 1/3. And then if I take the cosine of that, I get some craziness. Okay. It says the cosine is 9.4. It's something radical. Yeah. It's square root of 2 over 3, isn't it? No, it's not. It's just square root of 2. Yes, you're exactly right. Who is that? High five. It's square root of 8 over 3. Because you're going to square them both. Ooh. Okay. M, mu s, and physical constants. That's it. You know what? We'll look up later whether it says. Oh, we got 5 minutes. Okay. We'll look up later whether it says You have to have 1/3, 1/8, whatever they expect. Like they're deliberately. This is not the easier problems. This is a harder one. Yes, sir. No. Well. Sine theta. Whoa. Maybe we better look. We better look right now. Yep. We'll solve the mystery. Oh, if I can. Oh no. My my leash. So I thought I made answer keys to the free response also. Scoring guidelines? Uh-oh. I'll just set my headset down. You know what? For online people, I'll just post it online when I find it eventually.